Sequences, series, and sigma notation, let's go over the relationship between all three. So let's say we had numbers 1 through 10. Now, as you see, these numbers follow a particular pattern. To get from one number to the next, we're increasing by 1. And this is what we would refer to as a sequence. And a sequence is essentially a list of numbers that follows a particular pattern to get from one number to the next number. Now, some important characteristics of a sequence is that all these numbers are referred to as what we call terms. So in this case, the first value in our sequence is known as the first term, and we would denote that as a sub 1, and in this case it would be equal to 1. And then the second value would be the second term, so a sub 2 in this case would be equal to 2, etc. Now, with a sequence, typically we can generalize a formula to help us figure out what we call the nth term of the sequence. So in this case, a formula for this sequence would just be a sub n equal to n, because essentially whatever term you want to plug in, you just plug in that term and you'll get the value, okay? Now let's say we want to take it up a notch. And let's say now we want to take the sum of the sequence. So we want to calculate 1 plus 2 plus 3 all the way up to 10. Now, taking the sum of a sequence is what we call a series, okay? Now, luckily, instead of writing 1 plus 2 plus 3 all the way up to 10, we have a better way to denote it, and that's where the sigma notation symbol comes in clutch. Now, to denote this, we can represent like this. So let's break down what this means. Now, like I said before, this symbol that you see right here is known as the sigma symbol, and it represents summation. Now, this lower value is known as our lower limit. This is where we start. In this case, we're starting at 1. And then this value at the top is known as our upper limit. This is the place where we want to stop. And then, of course, because the formula for our sequence is a sub n equal to n, we're going to pass in n as our function or our argument of our summation. And basically, this is going to be calculating this. And ultimately, in the end, we would get a value of 55. But that's just a little overview of the relationship between sequences, series, and sigma notation.